This video is going to cover page 10 in your notes packet. This is essentially, my thought on this video was that, or this page, was that I would tell you everything you need to know about factoring and you could have it all on one page. The idea being, if you can go through this and take it step by step, you should be able to you should be able to graph these rational functions. So, starting with the zeros, I feel like that's the most important thing. Starting with the zeros, what we do is we look at the numerator. If it's not factored, we factor it, and then we set those numerators equal to 0. Those give you the X-intercepts. So once you find them, you just plot them on the X-intercept. Now, why do we do it that way? Well, when we find the X-intercepts of any function, we always set y equal to 0, and then we solve it. So if we set this function equal to 0, then if we plug in a 0 for y, well, the only way we could get that equal to 0 would be if the numerator were equal to 0. That's how a fraction is equal to 0. So I can tell that this x-intercept is going to have to be -2, 0, because that would make the numerator 0. And so then when I graph it, that's going to be on the x-intercepts. So that's why we do it that way. Let's take a look at vertical asymptotes. Let me go starting with the y, just because we were at that over here. When we have been studying fractions, we know that anything that makes the denominator 0 is undefined. You cannot divide by 0. If you do, you get an undefined answer. In other words, the graph can't go there. So that's why we do this. And what we do is we take that denominator, we factor it, and we set those factors equal to 0. And how do we do that? Well, we just plot it as a vertical dotted line on our graph. Another important thing about the vertical asymptotes can never be touched. Now, when we get to horizontal, that's a different story, but vertical asymptotes, they are never touched on the vertical asymptotes. Okay, holes. Holes are what happens when you factor the numerator and you factor the denominator, and anything that cancels, that becomes a hole. Why? Well, because it used to be, whether it's in the numerator or in the denominator, it either used to be a 0, but then we canceled it out, so it's not there anymore, or it used to be a vertical asymptote, but again, we canceled it out, so it's not there anymore. So it's no longer a vertical asymptote, but it does still leave a hole. That is how we do it, though, is we look for the factors that cancel. Once we get that, so I'll go back up here to the numerator, up to this example for a second. If I have this as my function, I could factor this to x plus 2 and x plus 1. And when that happens, these x plus 2's cancel out. Now, I just made that example up, so it's not a perfect example. But what's happening here is that used to be a vertical asymptote. But now, instead of being a vertical asymptote, it's just a hole. That is, it used to be, vertical asymptotes is like they have a force field, and you can't cross over them. Well, we've erased that force field, and so now it can go through it, but it does leave a hole. It kind of has little remains of it there, but it does leave it as a hole. So that's what's going on with holes. Y-intercepts. For any kind of function, for a y-intercept, we plug in a 0 for x and we solve for y. And then you just find that point and you plot it. Why do we want this? Well, the only reason why is that this is a helpful extra point to have on your graph. Because sometimes we get this graph and we don't know, is it supposed to go up here or is it supposed to go down here? Well, having a y-intercept is another place that gives you a hint of where it should be. Now, the last 3 items on the list are the horizontal asymptotes, the oblique asymptotes, and the end behavior. Notice that these 3 are mutually exclusive. You will only have one of them. Now, end behavior is a phrase that defines every function has an end behavior, but we've been talking about end behavior being positive infinity and negative infinity. In that case, horizontal asymptotes are another type of end behavior, and oblique asymptotes are another type of end behavior. So all of these three really go together. In general, you have to divide the function and memorize the rules on page 7 of your packet. And that is where I have outlined when is it the degree is greater, the degree is less, all of that stuff. You need to know that. And maybe it's not memorizing it, maybe it's just understanding it, but you do need to know those rules. The horizontal asymptote you will only use in two cases. There will only be a horizontal asymptote if, first of all, the degree of the numerator is equal to the degree of the denominator, or if the degree of the numerator is less than the degree of the denominator. And I'll show you an example of that in just a minute. Of course, we just plot it as a horizontal dotted line. Something special about this is the graph can touch it, and it can cross it. And that is a little bit different than the vertical asymptotes. So just keep in mind that the graph can touch it and cross it. Let's come down here to the bottom of the paper, and I have some examples under the table here. So I said if the degree of the numerator is equal to the degree of the denominator. In that case, like this, example A, my degrees are the same. They're both third degree. Then what you do is you take the leading coefficient. The horizontal asymptote is y equals 4/3. And the y equals 4/3, that is going to be 1 1/3. So that's just going to be a horizontal asymptote that looks something like this at 4/3. The other possibility is something like this. On this one, my denominator is greater than my numerator. And so what happens then, if I reduce that, I will get 1/x. And when we very first started learning about these, 1/x was a graph that looked like this. And this has a horizontal asymptote at 0. I didn't draw my line exactly there, but that has a horizontal asymptote at 0. Those are horizontal asymptotes. Okay, what about oblique? Well, you can have oblique. The oblique asymptotes show up only if the degree of the numerator is equal to the degree of the denominator plus 1. It just is 1 degree higher. And if it's 1 degree higher, then you have to use long division or synthetic division to find out what it is. When you do that long division, you might have something like, I'm just going to make this up here, something like 2x plus 5. So you do your long division, you get 2x plus 5, and when you graph that then, you just follow your y equals mx plus b rules. You start at 5, you go up 2/1, and that is your oblique asymptote. Be sure when you do this that you're following the vertical line test, because you'll have another vertical asymptote here, and just remember you can't have two on top of each other. In other words, if you have something down here, you will not have something over here, because that would not stick with the vertical line test. If you have something down here, then instead you're going to have something on the other side of the vertical asymptote. So you're either going to go over here, or you could go right next to it over here. Just depends on how your vertical asymptote, if it's even or odd. But just make sure you follow the vertical line test with that. End behavior. And again, end behavior is actually like an umbrella term that covers all of these, but they're just all each a little bit different. End behavior, what we've been talking about with end behavior is when it goes to positive infinity or negative infinity. It is only this situation where it goes to positive or negative infinity if the degree of the numerator is more than 1 degree higher than the denominator. So for instance, I have an example over here on the right. If we have x to the 5th over x squared, we would reduce that, and it reduces to x to the 3rd. And we remember from our polynomials, if it's x to the 3rd, it's going to follow this kind of a shape, positive infinity on the right, negative infinity on the left. And once again, with end behavior, it's only the ends that we care about. We do not care about the middle. It's going to have all sorts of crazy stuff going on in the middle. But the left end will be down, and the right end will be up. This page, page 10, covers everything that you could ever possibly need to know about graphing. It just has broken it down into steps so you can refer to this and you know how to graph piece by piece. You have to look for the pieces and put them together.